Good morning, ABM 11E. This is Sir Moy, a GenMath teacher. I'll be sharing you this video to cover the topic that we missed due to leave classes. So we'll proceed and continue on operations and functions. So the last time we met, last Tuesday, we covered how operations are done, how solving equations and inequalities are done for quadratics. And then we went to basic operations on functions, how it's done. So again, because we're going to deal with algebraic expressions, please make sure that your background on combining, simplifying expressions are of good quality. So remember that for this case, we're simply applying rules in combining algebraic expressions. So for us to deal with operations properly, please make sure you properly recall those concepts. So we'll be tackling sum and difference of functions, product of functions, quotient of functions, and lastly, composition of functions. I showed you the examples last time. We performed these operations, and in your end, some of you uh, had questions on how things were done here. Now, the next slide will be tackling evaluating functions and at the same time performing operations on them. These are as follows. Let's say f of x is 4x squared minus 1, g of x is 2 times the square root of x plus 4, and then h of x is 4 over x minus 3. Now, what will f plus g of 5 mean? Again, this tells us that we have a sum of the functions f and g, and then we're going to evaluate that function by using the value of 5. So basically means we substitute 5 into f and into g, and then we just calculate the result of the operations. 4 times 5 squared minus 1 is f plus g, which is 2 times square root of 5 plus 4. And from there, we end up with the value 105. So f plus g of 5 is 105. Next example, we have g minus h of 0. Same idea. We put 0 into g and into h. Then we take the difference of the values. From here, we end up with 16 over 3. Please check with your calculator. Next, the product of h and g. And then we take the value of the function using x equals 1. So h becomes 4 over 1 minus 3, and then g becomes 2 times the square root of 1 plus 4. And then we have negative 4 square root of 5. Next is this, composition. Now, for a composition, Be careful. Again, this means that we have to substitute 12 into G and then G of 12 into F. So what does this do? We get this. So you'll see here that square root of 12 plus 4 times 2, that's G. And the x of G was substituted by 12. Then this results to the output of G of 12, which will be used as input for F. So we end up with 255. Oh, sorry about the order. G divided by F of negative 2, same idea. We get the quotient negative 1 over 75. Now, remember that for functions such as these, you can combine multiple functions. You can perform operations on more than two functions. So here goes. What will be h minus f over g of negative 2? So negative 2 becomes the input for h, f, and g. And then you get this value, negative 5 over 12. So it's just substituting the value for x. Next, we have the product of f of g plus h. And then we substitute negative 1 for x. Excuse me. We end up with this value. Now, what happens if we do compositions? Now we have f of g of f of 2. Again, this would mean that we take f of 2 as the input for g, and then the output of that becomes the input for f. So again, 2 becomes the input for f, so we take f of 2 as the input of g, and then g of f of 2 becomes the input of f again. So from here we get this notation ends up with the value 11 over 23. So if you run the values again, f of 2 is the start, so 2 over 2 plus 4, that's 2 over 6, which is 1/3. And then we take 1/3 into g, so that's 2 times 1/3 plus 8. We end up with 26 over 3, and then that becomes the input for f again, bringing us 11 over 23. Now, what happens if we do f of h of x? We end up with this notation. H becomes the input of f here. So x becomes negative 4x over x minus 1. This x becomes negative 4x over x minus 1. And then we get this result. Our last example for this slide is h of f of x. So we get this substitution. X becomes x over x plus 4. X becomes x over x plus 4.